Okay, my name's Guzman from Khem Studios. My background comes from art fabrication. I was a sculptor, and sculpture doesn't bring in so much revenue. So basically I started to do a lot more fabrication, and that fabrication led me more into like CNC and Khem and CAD. So that's why you'll see in the shop kind of more about the machines and the process that I work with. We've been here for about 2 years, 2.5 years. There's still some quirks in the shop that need to be fixed, but I think everybody's shop has like a thing that hasn't been finished yet. I think ventilation wise needs a little bit more, but I'll show you around the shop. This is the front part. You know, material comes in, the garage comes open, I can bring all my material in, and large Bosch bandsaw, compound miter saw, saw stop table saw contractor. I really do like it. I do miss having a really professional table saw, but it's good enough, and it's great because I have all my fingers. I try to keep the shop as flexible as possible for space, so everything's got wheels. And then Grizzly is good tools. It's a good tool. It's a planer joiner. It saves space because you can flip it up. And then you can sit there and do the other side of the wood. Come over here, and this is more of the CNC or technically advanced side. So here we have a bandsaw for ripping up large timbers. We have a laser cutting machine, which is 16 by 30. So it allows you to do engraving, and it lets you, I don't have that many things, but basically it's a slicer and dicer of any kind of shape that you want up to 1/4 inch material. So it cuts plexiglass, wood, you can engrave on stainless steel. So it's really kind of like a really useful tool. I also use it for a lot of jigs. So if I don't want to use a CNC machine, I'll cut some 1/4 inch material, and I can use that with a regular traditional router. So that's a quicker way. Not to get too into it, but there's no blade that cuts the material. It's a laser that cuts through the material. So it's a lot easier to, you don't have to hold down the material while it's cutting. So you can just put the material in, and then this laser comes over and cuts it. So there's no mechanical engagement in the material. So it's a little bit faster instead of trying to figure out, with all woodworking or any process, holding down your material is really the big pain in the butt. So this is kind of a nice quick fix. It's right down to the Workhorse. This is the larger bed. This is 50 inches by 90. It's 5 feet by 8 feet. So it's oversized too, so it has an inch on either side, so you can take a full sheet of MDF, put it on, and then start cutting it. These machines are made for 2 different types. You can sit there and do sheet flat cuts, which that's where the profit is with these machines. So if you're thinking about purchasing one, tons of flat work is really great. You just put the material on, you get your file ready, and then you go. With the furniture stuff, you have to do a lot more jig making on the machine. But it's a 3-axis machine, so the spindle goes this way, and up and down. It's a spindle versus a router. There's a little bit of a difference. A router is basically has no feedback. A spindle, as it cuts through the material, it understands the resistance, and it tries to keep that RPM up. These are jigs here for, these are just different jigs. So I really think of this table as a work table. It's not a machine, it's like all in one. So instead of moving the material through a machine, it allows you to just place the material on the machine and then move the machine around your material. So there's just a lot, there's a lot you can do with design if you have a solid piece of wood sitting there and you have the blade dance around it versus trying to figure out how to manhandle this object around on it. So today, just kind of ramp up. I'm just going to get the stools and I'll show you what I have. To the stools, the first piece of furniture I made was a chair, and I moved up here and went to Sawkill, and he has lots of stools. So I was like, let me see how hard it is to make a stool. You know, so from a chair to a stool, and I always felt that stools were, you know, they're kind of like the more simple of the evolution of furniture. So it'd be kind of a fun project. We call it the ultimate stool, just to kind of get things going. And I was really into modular, so I wanted the legs to come off. So the first stool basically had hardware, and then the seam, that's where the seam kind of evolved. That said, it worked, but it wasn't really super strong. So I ended up gluing it and keeping the hardware just as, you know, part of the evolution to show the evolution. So this is the shop stool that was the first one done. You can see it's been beat up a lot, but it works great. It's nice. It gets kicked around. It's cherry. It gets darker. It's a nice simple piece. And then we're trying to make a little bit more fancy, and we went with the walnut. A lot of the first wave of furniture we made, my sculpture had metal plates, and I really like machining, so I really wanted to incorporate metal with wood. But I think generally speaking, a lot of people enjoy just a solid wood piece of furniture. Or if there is metal, it's like for drawer handles or like the little bottom of the feet. So this worked pretty well. Sold several of these, but we wanted to kind of do it without the hardware. So that's the walnut one. And this is the most recent one, basically ink with a varnish on top of it, and changed a little bit of the detail, softened the edges, and got rid of the little edge that was there because it was getting dinked up a lot. So I thought it would be kind of nice to have this edge just to kind of change it a little bit. But this edge, if it falls, I think that this is a better solution to have kind of a blunt for, you know, it's a stool, so a lot, you know, it gets kicked around a lot. People use it for footstools, so kind of just working through the ideas. The first thing we do is basically everything starts off like this. So it's more of a machinist idea of making furniture. Everything kind of has a stock material, and then it gets held down, and then it gets machined out. This is what comes out of it. So you have this piece here, you have this piece here that's machined out, and then you have this piece here that's machined out. And then you have the top here. So this goes in there, and then this goes in there. So, you know, the grain goes like this, and then it's at an angle, and then this is, you know, the grain goes this way, and then the grain gets glued this way. So this is a pretty strong glue up. And now we're going to cut this guy right here. This is a Toolpath. So if you look here, this is telling you you have to dial in all the speeds and feeds for your material. So if you're cutting wood, it's one speed. If you're cutting foam, it's another speed. And you have to tell it where to cut it and how deep to go. the next pass is a finishing pass that that's just going to come down and do a nice clean pass. So now it's going from a 3/8 bit to a 1/2 inch bit, which is it's just a bigger bit, so sometimes it's a better finish on the edge. So I cut it's just going to cut a 1/16 of an inch off all the way down. You know, it's just a finished edge right there, and then sanding is very minimal, and you can, you know, less sanding the better. The more you sand, the more your actual shape changes. So almost everything that I make, I put these registration knobs on it, so then I can flip it. So it just allows me for more, it just gives me more freedom, because if I make a mistake, I might be able to fix it because I know I can put it back onto these knobs and I can get back to it. Because I'm really good at making lots of mistakes fast, and I do redundancy so I can make mistakes and fix my mistakes as quick as possible. These are industrial hold down pucks. This was 150 bucks. It's just solid. It's of a rubber material that the size never changes in the heat, you know, and if you're dealing with a tool that can sit there and change, you know, a thou, this machine can shave off a thou, which is a very little bit off of it. So you really want to make sure that this doesn't move at all. And then you have the vacuum hold down system, which is this guy. There's several different ways, and this is just a huge discussion, but this is two vacuum fans that suck air through a system, and this knob gets pressed down when you put the material on, and it sucks the material to your pod. So the cool thing about it is that, you know, I can put two, you know, I can put four, I could put 8, so it really depends. Like if I'm working on a big bed post or something, or a larger piece of material, I could lay on this machine a 96 by 12 inch wide 2-inch plank, and I could machine the full thing. So you can do really big architectural pieces with the machine, or you can do smaller leg pieces for the machine. So, you know, so that's just what this system does. So this part of the table for me is my business end. The rest is for larger format stuff. So this is literally my bench made area right here. So again, this is all in the software at the same time. So it's, you know, it's basically mirroring what I've done in the CAD software. So it'll get a little loud, but I'm just going to show you what it can do. So if I turn it on, if your tool is pushing harder than I'm pulling, then the tool will break. I mean, it's just basically, so I mean, it really is great. And the nice thing about it is that I spend more time trying to figure out how to hold down a tool than I spend sometimes actually working. So I just kind of like this idea of like having it held down and sit there and it's solid. We're going to cut this piece out. So there's several things that you have to decide. One of the biggest things that happen is tear out. So, you know, if you sit there and cut something like this, the blade will hit here and also can tear it out. So when I machine whatever I'm machining, majority of the first cuts are cross grain. So I'll cut this first. I'll tell the machine to cut this first, and then it cuts this first. It does a roughing pass, and then it does one final finishing pass. So that means that the material is cut as close as possible to the edge that I want, and then I'll do a nice clean pass. When it's with the grain, it cuts a lot easier. So you'll see it do 4 different types of cuts. You'll do 1 cut, 2 cuts, 3 cuts, and then 4 cuts. And then, then the piece is done. Also, I'm not going to cut all the way through the material. I'm going to keep a little bit of it. I think it's called onion skin, but I'm going to keep a little bit left so then it's intact, and then I can do the trim router after that. First thing I want to do is to make sure that the thickness of the material is the same. So it's going to get fly cut, so it preps the top. The question being is, why not just plane the piece of stock first and then just cut out the profile? The reason why is because this has to fit into here, and this machine does a better job to make sure that this thickness is exact versus the planer and joiner. Could be human error. So if I touch the material more, there's more chances for mistakes versus if I touch the material less. So, what I do is I dress one side and then I put it onto the table, and then I will consistently always get the same thickness of this material to get put into that. So the leg works. After it preps the top, it cuts the ends. It finishes that cut, and then it does the long sides. So we can bring it over here. And that's how you make the ultimate stool.